All right, welcome to Physical Science. Today is Monday, 8/26, and I just wanted to let everybody know that the review sheet for the interim is available. You can find it at the bottom of Instructional Cycle 1. It's like the last thing at the bottom of the list there, and I'll put it in an announcement. I just haven't had a minute to do that yet today, but at the end of the day, you should be able to find that in the announcement. And no, you cannot take the interim now early. Yes, Ariel, we will have the first interim is September. My calendar's not flipped. September, the second week in September will be our first mastery week. Yeah, it is a little early, but that way it's covering less material, right? So think of those as your unit tests. So we have material this week and material next week. And then there were 4 last year, but they've gone back to 6. So we're back to 6 instructional cycles. So we're not going to have any like tests in here because I'm going to use the interims as your tests. Hello, Via. Hello, Hannah. Welcome, guys. And yeah, we'll talk more about that. You'll hear more about that along the way. But wanted to talk for just a second about fuel in space. Of the space probe. So this is the Voyager program is what they were discussing here and what they're going to talk about in your lesson today. So what do you know about space probe fuel? I don't think they run off of petroleum. That would be way too heavy to take up into space. But now it was close to petroleum. It started with a P, and it's a radioactive element. So can anyone think of a radioactive element that starts with a P? Not phosphate. Yeah, Avery, how are you? And hello, Hannah T. And Zuleika, yeah, plutonium. So they're using plutonium to run the Voyager 1 and Voyager 2. And these space missions were launched when I was a little kid. And they had less technology in them than is in this little graphing calculator. In fact, they probably had less technology than even a regular calculator. And reliable, that's not nice to ask me how old I am. But I was about, I was young, under 10. It was in the 70s. Oh, that's very sweet, Sky. Okay. Well, you know, I'm not going to tell you how old I am now. You can use your math skills to estimate that on your own. Give you something to do today, reliable. Okay, so they launched these in the mid-70s or late 70s, and they flew past Jupiter and Saturn and Uranus and Neptune and took some gorgeous pictures. Some of the first pictures we had of close-ups of these planets. And then they kept going, and they're still going into outer space. And one of them has reached the edge of the solar system. And so we're beginning to get data back about what is in the outer reaches of our solar system, which is quite amazing. And the reason that they can still transmit data is because of that radioactive plutonium they have that is making their engines work. Thanks, guys. That's some nice comments in there. I'll just read the nice ones that I like. Anyway, so to learn more about what happens to the fuel in the space probe, you'll have to do the lesson today, because it explains a few more things about radioactivity. I don't want to give it all away. All right, that's enough about my age. It's enough about my age. Anyway, there you go. That is nice and respectful and courteous to, yeah, I understand, Via, to stop with the comments when I ask. So appreciate it. And yeah, you guys are great at your code of conduct. So let's do a knowledge check. And remember, red X is I don't know. I'm not sure where my red X went. I really thought I had it in here, but all right. So use your emojis down here in the bottom left-hand corner. All right, I would love to see some more answers. And hello, Sahir, and hello, Michaela. Welcome. So I want to point out to you, just to remind you that over here are the non-metals. It's a pretty small area. Okay, thank you for letting me know, Sahir. But they're separated really into 3 sections. We've got the non-metals, the metalloids, which are just down the angle here, and all the rest are metals. And let me, one of my wonderful coworkers made this annotated version. Let me see if I can get it to come up here. Haha, there it is. Let's see, all right. Did it bring that up nice and big there? The periodic table, can y'all see it? Gigantic. Okay, so on the right, and I wish I could like show my mouse over it. On the right, you can see all the pink and the blue and the orange all over to the right here. Those are all the non-metals. The yellow part down the angle there, those are your metalloids. There are 7 of them. Everything else is a metal. All right, so those are both down in the image category, which is right down below my finger there. So you can open those up at your leisure whenever you want. I just click on one of them and it pops up big. So I'm assuming if you click on them, it'll show up for you too. You know I love the taco. Okay, so we've got non-metals, right? Noble gases are a very small group, like the non-metals. The metalloids, there's only 7, so they're a little group too. Thank you, Via. And so the big group are going to be the metals. So turtle is the right one there. So if you were unsure, and now you are sure, go ahead and give me that turtle so I know that you got it. And hello, Samaya. Yes, excellent. I think 80% of us, 70 to 80% of us were right on there at the beginnings. Good job to you guys. A second knowledge check. We tend to do 2 of these a day. Non-metals tend to boil at what kinds of temperatures? Oh, let me, sorry. I'll just let you change them. I forgot to clear it out. Sorry. So non-metals tend to boil at what kind of temperatures? Oh, well, Sky, it's a little bit different. We talked about the melting temperature, I think, before, but the answer is going to be the same as the boiling temperature. This is when we were talking about the properties of non-metals. So if you need more about this, you would go back to the non-metal section. So let me explain a little bit, and then you guys can keep changing up your answers till you're happy with it. So most nonmetals are gases, right? Oxygen, nitrogen, fluorine, chlorine. I mean, some of them, like sulfur, are solid. But for the most part, they're gases, like the noble gases. And so they are gas right now. So they've already boiled. So in order to turn them back into a liquid, right, we have to cool them down. In fact, oxygen won't condense until negative 300 degrees Fahrenheit. Nitrogen won't condense until negative 320 degrees Fahrenheit, right? And y'all know that boiling is liquid turning into a gas, right? So liquid nitrogen turns into a gas at negative 320 degrees. That's how cold you have to get it to make it turn into a liquid. So that is a very low temperature. Yeah, it's going to be turtle again. Double turtle today. So think about the metal. Remember the metal car? What do we have to do to make the metal boil? Yeah, it's gonna, you have to heat it up until it melts, and then you have to heat it up some more until it boils. So metals are gonna boil at a very high temperature. And each individual item, each individual element only has one temperature at which it can boil. So that's why the varying temperature is wrong. As long as you have a standard pressure, like our atmospheric pressure, then iron will always boil at the same temperature. Water will always boil at 212 degrees Fahrenheit. So they're not going to vary as long as you keep the pressure constant. Okay, so I see almost all turtles. No more red X's, so that worked out really nicely. Okay, so today we have something brand new. We are kind of closing out the periodic table. Since we have something brand new, I thought I would introduce that with a quick little video. So watch, and then we'll check back in a sec. Cool. And those guys at the end are those that discovered the radioactivity, and Marie Curie at the end there too. So we're not going to cover all of that today, of course. The main thing is that you recognize that radioactive decay, they give off particles, it changes the nucleus, that kind of thing. The half-life calculations, yeah, when isotopes are unstable, they kind of fall apart to stabilize. We're going to do the half-life calculations on block day. So that'll be on Wednesday. So you're not going to worry about those today at all, block day. And so you can kind of zoom through the calculation part. And then you want to definitely take a look at their isotopes. Questions about anything in the video? Alpha, beta, gamma, positron? I didn't make the videos, so who knows? I haven't had a lot of time this year to make videos, but maybe once things get used to all the systems, I'll start back making a couple of videos here and there. Oh, so reliable. If you ever want to share one of your Kahoots that has to do with our topics, you certainly can. All right, so time. Yes, I would love to use one of your Kahoots. Yeah, definitely. Let me know about that. But it's time to spend a little bit of time working in Canvas. So let me know when you're ready. I'll give you, you give me a green check and I'll put you in the quiet workroom, and then we'll reconvene right at the end of class to take a look at what you did. All right, I have brought you guys back from the breakout room. So we can just kind of recap and make sure that you guys don't have any questions. Let's see. So, goodness, hang on. I was trying to do something different here. There we go. Make me smaller so you can read the PowerPoint there. So the main points here was that the spontaneous discharge of radiation is radioactivity. The nuclei are unstable. And what did you guys find interesting about the useful applications of radioactivity? Yep, they use radiation to detect cancer. And to treat it. Excellent. They can detect other medical issues too, not just cancer. Right, or they can focus it. Like I know they have a gamma knife where they can focus the gamma radiation right onto a tumor, and then it really just harms the tumor cells. Yes, you can find out how something old is, how old something is. That's the archaeological application, and we're going to talk more about that on our block day, which will be on Wednesday for you guys. It's an odd day. And yeah, we use the carbon-14 that we saw in the video that gave off those beta particles. Right, geology is the study of the rocks, so they can tell when the rocks were created. Yeah, and it's based on the half-life. Depending on the half-life of the element they're looking at, can give you a range of how old things can be. Cool. So those are all the uses. And so we will end with a little matching practice. So give me a word, one of these 4 words, and one of the 4 letters in the chat. Cool. So a word with a letter. Oh, or all 4 answers there. Anyone else coming up with CDAB for the answer? Well, that is correct. C for percentage is a part of the whole. Half-life is the time it takes for half of it to decay. That's what we'll do the calculations for on Wednesday. Radioactive decay is the whole process. Radioactivity is the spontaneous discharge. So how are you guys feeling? What's your level of understanding here for our new topic? -16. So if you are struggling with this, then tomorrow when I send everybody off to the breakout room to work and you want to talk about this more, I just stay in the main room and I'd be more than happy to talk to you about anything that you're struggling with. It doesn't even have to be a current topic. It could be something from last week or the week before. But know that I'm here to help you guys. And so if you need some one-on-one time to ask questions, that's what that is for. And you can also email me or call me, and I'm available, especially in the morning before 10 is the best time to give me a call if you want to talk about something on the phone. And I've got to go, and class is done because it is now 2:55. And so thanks for coming in. I will see you all tomorrow. Have a wonderful afternoon.